Hello, welcome everybody. You are joining us for a quick talk. This is our speaker, Jared Diebold. He is the U.S. PV Sales Manager for INGETEAM, Inc. His presentation today will be Energy Efficiency, SmartHouse. A little bit more about our speaker. He has been with INGETEAM, INGETEAM's U.S. Wind Power. He's been, INGETEAM's U.S. Wind Power Sales Manager since 2011. He has lots of experience within the electricity sector, working as a sales and marketing director at Badger Magnetics, as product specialist at Eaton, as engineer at Metal Tech International, and at Franklin Energy. Go ahead.
All right, hi. I think my topic was energy efficiency. It got a little bit cut off, so I'm going to also speak specifically about SmartHouse application, product availability to self-consume energy consumption for your residential house applications. Just giving you guys an introduction of product overview, what's available out in the market today to consider instead of consuming all of your power for your household use from just the power provided by the grid, that you can apply different generation capabilities at your household level so that you can self-consume, you can integrate different technologies. So the idea is that with the SmartHouse idea is that you got a controller in place that's going to be able to more efficiently control the different options in your house. You can have wind generation, now becoming more popular, battery, electronic vehicles. People are always interested in hybrid, off-grid solutions. You've got PV panels that can be installed. So instead of just exclusively powering your entire household from the grid, you've got a lot of options today. And the controller is going to be able to communicate even with the loads, electronic loads that you might have for your house, whether it be even electric heating or otherwise, to even have the capabilities to try to turn those off when possible. And then we're always going to be measuring back and forth between the grid consumption so that you're always self-consuming. There's certain utilities that don't want you to actually generate power back into their grid at all. So the controller is going to maximize just the self-consumption of all the power products that you're producing on your site. So PV, of course, you need the PV panels, and then you need the inverter. The inverter is what's going to convert that power to usable grid connected power. You're going to connect that into your household usage and allowing you to take advantage of all the photovoltaics either on the ground mount or on your roof mount system. And that's going to communicate into the controller. The idea, obviously, with PV, we're at a solar show. I don't think it's any surprise on how PV really works, but on how the inverter works, it takes advantage during the temperatures and the high irradiance with cloud cover, no cloud cover, to maximize the amount of power that it's going to be able to produce out of the PV panels. As you know, they fluctuate with temperature and, of course, location. And that's the job of the inverters, to extract the maximum amount of power to be able to produce the amount of AC power into your system. For micro wind generation, could be another optional generation source that you could have at your household or site. You, of course, need an inverter to be able to connect that into your system. It's another, sometimes the micro wind could be an AC or a DC source, but that can be an optional source that's injected power into your grid. Again, it's going to also connect into the controller to make sure that you're maximizing the amount of self-consumption. And when you're talking about off-grid or DC powered by batteries, you're talking about a hybrid inverter. A hybrid inverter is going to allow the inverter itself to create the reference voltage and the reference frequency versus a grid-connected inverter. But that inverter's job is going to obviously to charge and discharge the batteries properly to the actual status of charge and the discharge and charge rate that's determined by the actual battery manufacturer. It's the inverter's job to properly do that, but you have to make sure that you're not consuming too quickly or too slowly the battery charge, otherwise you could lose the life of the batteries. So proper integration with the actual right battery and to charge it and discharge it based upon its profile curves will ensure the long life of the batteries on your system. And of course, becoming even more popular too. More and more people are getting electric vehicles. This could be another source for more smart home usage, as you've got potentially an even a battery charged vehicle that you have on your site. EV chargers are becoming more and more popular throughout the entire world. And then the brains of the bunch is the manager, the controller. And this is what's going to know the loads, the power outputs of all of your potential source generation that you have at your facility or your house, whether it's batteries, the PV, or the wind generation. And this is what's going to control so that you're always self-consuming up to 100% of your load that's being consumed by your house or your facility. And it's the manager that's going to turn off loads. It's going to be the one that's going to communicate into all the different pieces of equipment. Ethernet and RS-485 are the most common communications protocols that they would work, but there's others available. But primarily Ethernet is capable. So the source being the grid, if you will, has the capabilities to, again, connect into your different loads, whether it be heat, any example. You want that also to be able to increase the amount of self-consume by being able to turn off some available loads that you have on your system. And then here, the power meter. This is what's actually measuring what the consumption and what at the point of the grid. So then if you're connected into a grid system that utility says, I don't want you to ever generate power onto my grid, I want you to only self-consume. This is what's actually taking the load measurement, metering it from what is being consumed at the grid, and it's sending the signal into the controller, so then it will actually turn up or turn down the amount of PV or generation that is actually being used, but never over an abundance, so that you don't push into the grid if the utility does not want that. Just a couple examples of where this is being, where we've integrated this. Originally from Spain, so a lot of our references are European references here. But they're just integrated this manager for self-consumption by just using PV in this application. And the biggest one to consider here of actual data output from this household usage is that orange, if you will, colored, up to 100% self-consumed power. So they're enough power is being produced out of the PV modules, so they do not need to supply any power from the grid to be able to meet the loading of their usage. Just another simple and final example, this one being a little bit larger at 100 kW at this site here, multiple of the PLC managers to properly coordinate into this because it was more complex of a project. And here, another example that, it's taking advantage of the sun, high radiation in the middle of the day to be able to produce in this particular site almost 50% of its power just being utilized by the sun itself. So again here, by being able to have the PLC controller, your various loads, all this can be much more smartly done at your household usage level, that you can have a lot more options than spending money on just consuming power from the utility to be able to just self-consume out of your own household or site location. The idea here is, of course, purely by grid to being able to control this and take advantage of this, and even utilizing batteries for later part of the day as they're fully charged to really take advantage of generation on your site. Any questions? Sure. Those two references were 2012 and 2013. Well, pretty consistent. I mean, it's just PV integration into those ones, so then that they are taking advantage of the sun, and the units are been installed since then, so there's no differences or changes. They're taking advantage of it throughout the year. I'm sorry? Well, it could be anything that could be electrical. I mean, whether it be heating or HVAC that you could possibly connect into. If you go back to the previous slide, there are certain limits that are limitations on just power output of those, what it can connect into from the controller. Just with here stating what the amount of wattage and amperage that's maximized by H1 that the controller can maximum control. So as long as it's electrical load, I mean, it's an opportunity. It could be. Boiler, could be, I mean, here's just two examples of radiant heat, electrical. It could. And then the amount, like that one was a 100 kW system, was a little bit bigger system. That's more commercial. I mean, a household, you're looking at only 3-4 kW at a time. So that was a little bit more complex. You saw actually in the picture of it, it had a couple of the managers in it too. Europe pays a heck of a lot more in electrical, so their ROI is a lot better than Midwest United States. But in Hawaii, it could be more sooner ROI too. So I'm going to answer your question by saying it depends. And it's true, it's site by site. You know, you try to optimize the amount of PV to maximize could help. And if you've got a good price point for modules, I mean, a lot of things outside our individual products that we have, I couldn't give you an answer. All right, yeah. What's that? Yeah, you could, with the, similarly to the hybrid inverter, could be a different source of generation that could potentially be connected in here. I don't know we can talk more on what type of actual generation that you have, but an inverter like this could be also connected to a diesel genset of some sort. And then that diesel genset, again, it's being used since this is a voltage source inverter, which is creating that voltage frequency to establish the grid. In an off-grid situation, that could be used in like a backup power, or could be even connected to PV or batteries. But this type of inverter is a hybrid inverter that could allow for that. This one or the end chart? Yep, that one here. Okay. So you're consuming at the beginning of the day. You have no battery power. It's nighttime. Any load that you have on your site, you need to supply from the grid. Then starting in the morning, you've got coming online here the irradiation, which is the arc curve. On a nice sunny day, you're taking advantage of PV. PV is, you're actually generating more. If you look on the graph at around that, between that 8 and 10 o'clock, for example, on the screen, and that orange is showing that you're actually producing more power. So you're actually already meeting the 100% self-consumption. In this case, then you could be able to use that additional generation to charge the batteries. And then, you know, if you've got a cloud cover or you're consuming more load, you're gonna also take from the grid or the batteries. In the example that 10 o'clock, your load became greater, but you had some charge in your batteries, so you're gonna actually consume it via battery instead of from the grid. So you're not paying for that power. Then the case, then you're also potentially, I mean, this graph shows some injection into the grid too. That red area, if you're doing just exclusive self-consumption and you're not allowed to inject into the grid, that red area can be considered to charging the battery. You're at 100% self-consumption because your load in this case is highlighted in the light yellow. And then that load, it becomes greater at the end of the day. So you're going to then discharge batteries until they reach 0% state of charge. And then you start all over the next day. So it depends on if you're doing, you can set the controller to either push power into the grid or just exclusive to self-consumption. Well, if you also consider for the red too, if you're charging during red. could be possible. I mean, it's also energy. I mean, it depends upon your battery size. It's actually a battery power. So then, but that over time is your energy. So that's just discharge over time. If your loads go up higher, and this is just as an example, if you say your consuming loads go higher, then you would actually just shorten the amount of green because you consume the batteries in a faster state. So the sizing of your batteries is going to dictate the amount of total energy time period. Well, we stand behind the warranty, but that's warranty for the product. You know, there's of the individual units that there's no faults, that they're not performing properly. But there's not a lot of moving parts in a solar system to begin with. Batteries is direct any type of warranty you have to maintain with the battery manufacturer because that's who you bought the batteries from. Batteries are still expensive, and their warranties generally are the toughest part of this entire system. So the amount of batteries on your system sometimes is dictated by price. And you're gonna, there isn't a lot of moving parts though, so the amount of maintenance. I mean, for an inverter, you're looking mostly at fans. If there's a failure, then you would come to the individual inverter manufacturer. If it's an INGETEAM inverter, you would contact them, where it could be any spare parts sent out to site to be switched out by somebody who should be a qualified technician, somebody who may be an electrician, or somebody who's probably more than the average homeowner. You know, whoever your electrical contractor who helped you set this up might be more qualified to be able to work because they need to be qualified enough to know how to properly disconnect from the grid, so they know harm can be done to them, wear the right PPE gear and everything, so could be them. Sure.
Remote control,
yeah, if you're considering that you need to do only self-consumption, you can, the PV inverters, for example, could be even set to change to extract maximum power, and they act as like a negative load on your entire system, but then the controller can limit the amount of power that will be used in the system so that you only maximize at 100% for self-consumption. When, you know, there's more, like in the orange and the red area too, if you push or not push into the grid could depend upon if you set the inverters and the controller to allow just self-consumption mode, or if it's allowed to inject into the grid and say you can maybe do net metering, or you've got a retail rate or something if there's an additional meter there from whatever utility in the globe. Well, if it's available, I mean, on a cloudy day, or you don't have a charge in the battery, or you know, wind is not blowing, I mean, you're gonna have to consume from the grid because you need to power your computers, your lights, or whatever. The idea of this is just to try to lowest cost of energy possible when it's available too. I mean, that's the always the issue with PV. It's not available every single day of the year, but when it's available to you, to try to take advantage of it so you are no longer buying power from the grid when possible. And a lot of grids, they set up your electrical rate based upon the peak power that at some time you did consume, and then the amount of energy that you're consumed at whatever the rate might be. But the idea is you're still gonna have to consume on that top graph as an example if your renewable energies are unavailable to you on a given day. Also, I mean, you could consider that during low times that if connected to the grid, that the batteries still could charge from the grid, and then they become charged overnight, and then they'll try to consume right away to reduce the amount of energy you need, and then if the sun comes back up, then it can also act as to try to charge back up your batteries. the idea of the controller is to try to consume as little energy from the grid as possible. Be as close to 100% self-consumption as possible.